Hello everyone, this is Srikanth working as assistant professor in electrical department. In this session, I want to give one more problem on compensation theorem. So we need to prove the compensation theorem using one small network. Here I have a network. Question is, I need to prove the compensation theorem at R delta equal to 3 ohms. So my resistor is increased, changed to 3 ohm resistor. So I need to prove the compensation theorem at change resistor is 3 ohms resistor. R delta is 3 ohms. Now, I have a circuit now. 10 volts as well as 2 ohms, 6 ohms and 4 ohms. 4 ohms is your load resistance. Now, so my circuit is changed to some R delta value. Now, my circuit is, this is my circuit. Now, my R delta value is 3 ohms. So, at 4 ohms branch and it add the 3 ohms resistor. That is R delta resistor. Now, my R delta resistor is 3 ohms. So, this is your circuit 1 and this is your change circuit, that is circuit 2. Okay, circuit 1 as well as circuit 2. Now, my current value. So, my current value is at circuit 1, that is I value, and at circuit 2, my current value is I dash value. Okay, now, just find out the I and I dash values. Okay, just find out the I and I dash value using any method. So, if you want to use the mesh analysis, if you want nodal analysis, if you want source transformation, any method you can use. And just find out the I and I dash values. So I will move to the mesh analysis. So simple method. So how many loops we have? 2 loops. So loop 1 as well as loop 2. So at loop 1, you can say I1 current. Loop 2, I have the current is I. And just write the equation for loop 1 and loop 2. So loop 1 equation is, so I is 2 plus 6. So 8 I1 and at 6 ohms, both currents we have. At 2 ohms we have only one current. At 6 ohms, we have the 2 current, that is I1 is downward direction, I2 is upward direction. Okay, now at 6 ohms, we can write voltage drop at 6 ohms is I1 minus I into your 6 ohms, depending upon loop 1. If suppose loop 2, that is I minus I1 into your 6 ohms. Voltage drop at 6 ohms. Now, I want to write the equation directly using mesh analysis. So that equation is I1 into 8. I1 into 8. So 6 plus 2, 8 minus I into 6. So I1 is downward direction, I is upward direction. So that value is I into 6 equal to voltage source 10 volts at loop 1. At again loop 2, I have the equation minus I1 into 6. Again at 6 ohms, I1 is down direction, I is upward direction. So I need depending upon loop 2, I need to write minus I1 into 6 plus I into 10. 6 as well as 4. So total 10 ohms. So I into 10 equal to any voltage source we have. We don't have any voltage source, that is 0. So 2 equations, 2 unknown values. Just solve this equation, we'll get I1 value is 2.273 amps and I value is 1.363 amps. Okay, now circuit 2 again I have the 2 loops. So 2 loops, again 2 equations. So loop 1, now my current is here I2, just assume I2, and loop 2 current is I dash. Loop 1 current is I2 and loop 2 current is I dash. Okay, again write the equation using mesh analysis for both loop. Now loop 1 at circuit 2, loop 1 is I2 into 8. So 8 means 2 plus 6, 8. Now minus I dash into 6, same as circuit 1. Why means I dash is upward direction and I2 is downward direction, equal to your 10 volts resistor. Next, at loop 2, I dash current. So at I dash current, same as minus I2 into 6. Why minus means, again I am depending upon the loop 2. So at loop 2, your I2 current is reverse direction. So I need to write the minus I2 into 6 plus. So how many resistors we have? So now 6 as well as 3 as well as 4. So total 13 ohms I have. Total 13 ohms. So 13 into your I dash. So I dash into 13. Equal to any voltage source? No. Equal to 0. Again, 2 equations, 2 unknown values. Just solve this equation. You can get directly I2 equal to 1.912 amps and I dash equal to 0.882 amps. Okay, your I value is 1.363 amps at circuit 1, and at circuit 2 your I dash value is 0.882 amps. Now I need to compensate, I need to prove the theorem. So for this, I need to compensate some voltage to my circuit. So where you want to increase the resistor value branch, where the resistor is increased, that branch I need to compensate some voltage. So for this, my circuit is now, this is my circuit and your voltage source. I have the voltage source. That voltage source is replaced with internal resistance. That means short circuited. So your voltage source is short circuited. And what about the V value? So your V value is nothing but I into your increased resistor value. So what is your I value? 1.316. So you need to write the V value here. I equal to, so 1.364 into 3. 3 is your change resistor value. So this is your I value and this is your change resistor value. Then your value is, voltage value is 4.092 volts. Then I need to find out the I delta current. So my direction is upward direction. Just observe the upward direction and your formula will be changed. Okay. Then again, 2 loops. So 2 loops means 2 current. So now in this branch current is, I will say like I just assume like I3 and write the equation for each loop. So from loop 1, so how many resistors we have? Again 2 and 6. At 6 ohms we have 2 currents. So that is both are reverse direction. Then your I3 into 8 minus I delta into 6. That is loop 1 equation, and loop 2 equation we have the I delta current. So minus I3 into 6 plus I delta into 13. That means, so 6 plus 7 we have the 13. I delta into 13 equal to any voltage source we have. Yes, we have the voltage source, that is compensation voltage, that is 4.092 volts. Just solve those two equations, we will get like I3 as well as I delta value, but I require the I delta value. I delta equal to 0.481 amps. Just prove your theorem, that is compensation theorem. I delta equal to I minus I dash. Just substitute those value here. So I is 1.363 minus, so I dash is 0.882 amps. You'll get like 0.482 amps. So you can prove like this. So your delta equal to I dash minus I. Just substitute those values, you get the delta value directly. So we have 3 circuits. So circuit 1, circuit 2, circuit 3. At circuit 1, I need to find out the I value, and circuit 2 I dash value we have, and your circuit 3 I delta we have. So when we have the I delta value means, so compensate some voltage at last circuit, third circuit. That is V is I into R delta. So I value which you have from circuit 1, that is I value, and your circuit 2, so that is change resistor value. That is nothing but your compensation voltage value. Then you need to find out the I delta. So your I delta is nothing but I minus I dash value. So this is about compensation theorem. But I require the main circuit and compensator circuit. So my main circuit is, this is my main circuit, and I know the values for source current as well as your I value. I know the value from circuit 1, same circuit, same equation. Then your IS, that means source current, is 2.273 amps as well as your I current. So which current we have? That is 1.363 amps. So now clear. Up to here we have the main circuit. But I need to compensate same circuit to another circuit. So I have the voltage source, compensation voltage, that is 4.092 volts. Okay, so your main circuit is compensated to one more circuit. So that is, we have change resistor is 3 and your resistor value is 4. Your total resistor is 7 ohms. That 7 ohms branch I compensated some voltage, that is 4.092 volts. Then just find out your source current as well as your current branch, I mean the load current value will get like same. So again 2 equations, 2 unknown values. We have the values, that is IS as well as I, same. So your main circuit, which current we have, that means source current as well as load current. If suppose your circuit is changed to some other resistor, then you need to compensate some voltage. After that also we have the same value, that is IS and I, both values are same. So which value in main circuit which currents we have, same current we have, same value we have after compensation voltage. So like this we need to prove the compensation theorem. Now I want to conclude. So I have the main circuit. So I need to prove the compensation theorem at 3 ohms resistor. So your R delta is 3 ohms. So your load resistor is changed to 3 ohms. Okay. Now my load resistor value is 4 ohms. That changed to 7 ohms. Now at circuit 1, I need to find out the I value. At circuit 2, I need to find out the I dash value. So when the load resistor is changed, at circuit 3, I need to compensate the voltage to that unknown branch, load branch, and I need to find out the I delta value. Remember, the current is upward direction. Your I and I dash current is downward direction. Formula is I delta equal to I minus I dash. This is your formula. So you can prove directly. Otherwise, you want to prove more means your circuit, your main circuit is compensated to one more circuit. So when we have the load resistor is increased, then we need to give the some compensate to that circuit, that is voltage source to that branch. Then which current we have at main circuit, same current we have to last circuit. So compensator circuit. Okay, this is about compensation theorem. Like this you can prove the compensation theorem. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.